Hi, hi, hi. Hi. Hi, hi, hi. Internet will hear me. Well, hi, 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 hi. No, we can't hear anything yet, but there, like green bar is, yeah. No. Hey, hi, hi. So we get a bit more volume. I think there's something.
Hi.
Now we can get some. Yeah. Yeah, let's use that one. Yeah, that's for the, at least for the old speaker. Yeah. Okay. Seems like we have everyone in the venue now. Cool. Welcome to the, I think it's the 5th CNCF and Kubernetes meetup now. And I'm Lucas Kjellström, CNCF ambassador in Finland. And together with Anni and Teemu, we're organizing this meetup. Today we have the pleasure to be here at Elisa with a great venue. I hope you enjoy the food as well. And yeah, myself, I'm coming just right from the military, doing my military service from Dragsvik, and now after this is finished, I will have to go back. But
thank you for coming, everyone. As always, grab as much as food and drink as you want, and if you have anything to say, praise or whatnot, you can always tweet at us, and I'll be responding and whatnot. So all the tweeting happening. Yay!
Welcome on my behalf, very warmly. There is also somebody probably watching the stream, so everything will be streamed into internet, and let's hope that we will get everything right, video and sound. We have had some technical problems, probably not related to Kubernetes or anything else, but sometimes that happens. Also, I'd like to say that once again we have around 100 attendees here. I don't know, I'm not sure if there is 100 in this space, but at least they have tried to come here by clicking buttons.
yeah, it's pretty good. And today we have a record of 5 talks, so they will be a bit shorter. And after these 5 talks, the first one is the introductory words from Elisa and how they use Kubernetes. And after that, we have a couple of others. And after all the talks, we have some time for networking until 9 p.m. when we try to close and go back. But yeah, if you have something to, as Anni said, to say, tweet at us and we'll share or answer. Thanks.
All right. Warm welcomes on my behalf. I'm Tomi Pari. I'm head of service operations in Elisa's software services. Couple words about. Let's see if this works still. It works. Wow. Couple words about Elisa that might come as a surprise for you. Elisa's 135 years old startup. So we have started in 1882, which is quite long ago. We have quite a much of kind of legacy because of that, but we have also been always driving innovation and driving new things. And for us, kind of the next new thing, and kind of representing the business unit where I'm from, is the kind of digital services. So I come from the software services. It's a business unit which do kind of Elisa's digital services for consumers and some corporate projects. We do kind of products, not kind of custom development or any kind of that consultant thingy. So we are bunch of hands-on doers, developers, UX designers, architects, DevOps, whatnot. We try not to kind of employ so much hand wavers, managers, but we have a few of them as well, but mostly developers. We also use external workforce, consultants from about almost every company in Finland. But we have about 120 internal Elysians working on those digital services that we do. God damn it, this mic is annoying. Let's see if I can fix it. Okay, now it's better, I think. We have been building up a software-driven cloud in Elisa. If you have been any of my presentations before, you know what software-driven cloud is. It's a mixture of OpenStack and Kubernetes, which became then OpenShift. So we run that actually in production. Couple cases, we have multiple projects there, but kind of one of the largest one is Elisa Viihde, which we run the VOD, catalog and rentals and everything related to that, except the streaming inside and OpenShift, which is Kubernetes, as you know. Couple kind of key benefits for us has been that when a developer starts a branch on GitHub, it gets automatically deployed on the OpenShift for kind of development environment and kind of test environment. So each branch in the GitHub is actually deployed in the OpenShift, which means that in kind of previously we have a problem that we don't have enough testing environments, but now we have unlimited number of testing environments. And it's actually helping a lot with our development phase. Another thing which is kind of near to my heart is the Elisa Son. So we have actually started a kind of internal startup called Elisa Automate, elisaautomate.com. We sell digital automation services to other operators around Europe. It again started internally, so we did first internally self-organizing networks chosen to Elisa's mobile network, and we kind of figure out that, hey, this is actually pretty cool, and other operators would benefit from it. And so now we have a commercial deals with other operators around it, and it runs, the Elisa's environment runs in our software-driven cloud. And we have a Santeri who will talk a bit more about it. But kind of for the benefit for kind of network sake, that the self-organizing network is actually beneficial for our end customers, like hopefully you. We have a few kind of marketing slides here, but this actual use case, this is the average speed from one base station where we started automation, automated optimizing. So the lowest speed got kind of raised from 4 to 8, which is kind of quite amount of increase. I try to be quick. Yeah, Santeri.
Thanks. Am I on? No, not too much. A bit more now. Yes, good. So, Santeri, nice to meet you all. We already, some of us met at the lobby. I have been working with Elisa Son, part of the business on developing it for a half a year already, 1.5 years already. And I'm going to go through the basics, what we are doing, the big button. Cool. And give you a context and share a bit of a statistic from our production, and in the end, the lessons that we are trying to learn ourselves and keep in mind when doing stuff like this in the future. So We have a simple microservice. This is the data line or the data flow through the system. We read stuff from the mobile network, from the base stations. We transform the data into a ELISASON domain model. We run the algorithms on top of it. We generate new configuration based on it. Oh, sorry. Those configurations that the algorithm suggests generates a plans for the live network that are provisioned in, and then we start to figure out the best one for the next day. The basic problem behind is that we have multiple networks, and the day network is always in constant motion because we are, as an operator, building more base stations. The triple building is coming up on the next year. There will be more people around it. We have to increase the capacity, adapt to the changes where the people are going, and of course deploy new technologies so we can keep up with the modern trends. So this simple 5-step trick is done for all major vendors: Nokia, Huawei, Ericsson. Rules and conditions apply. We have a quite vast array of different technologies that we have to use. We have to adapt into different interfaces. We have stuff that is running on JSON RPC, SOAP, Nokia stuff. Some of it uses Bash interfaces that are calling Java objects. We have Telnet in our production environment. If somebody knows what Gorba is, good to you. XML is a constant burden because, well, there's so many unbroken documents that we just have to read in. FTP is still in use, and the list goes on. We have a multiple vendors of different providers of different technology styles from throughout the years. We are still running 2G networks. We are still having those old infrastructure in place, and those are in operation, and we have to update those ones. So when we read in the data, we are reading from multiple sources, and we are doing this one big batch run each night, every night, no exceptions, on Christmas Eve and on Midsummer. So the system have to be up and running. Example algorithms, if you know anything about radio technologies or optimization of radio network, you have already met the adjacent neighboring cell optimization problematic with 3G. That is quite a good trick that we can pull off. We are basically managing the routing infrastructure of cellular network and deciding what is the grid for the next day, where your cell phone should jump when you are in this area or the next one. What are the allowed transitions within the network? So how the balance of the traffic is shared within those around you. It's not equal always. Then we have a route sequence optimization, which is improving the radio performance in a radio interface, and basic load balancing targets with hopping on between multiple frequencies. Basics on that one is that lower frequencies, 800, is heard from farther distance than the higher frequencies near the base stations. So you have to decide where to move and what time. So these are complex problems that are solved by our doctors, our expertise in running the ISP. And these are also the algorithms that we are selling for the customers. So just to give you an idea of the operation, here is a snapshot from our containers that we use. We have a microservice, and we have different types of containers running. We have algorithm that is just a run context for the environment that you want to use, which is based on SDK base and SDK documentation. We have the API, which is the data backend representing the data for the algorithms. We have front end, which is mostly JavaScript. We have a separate cleaner process that just keeps the disks free of data. Counter API for all the monitoring data that we are reading in and representing for the algorithms. And exporter and importer, which are part of the pool that we do, converting the data into different formats so we can use it in different stages. So from these components, you can spot a big difference between the sizes of the containers. And the most problematic one is the algorithm container overall, because it has NumPy in it. It takes Debian, I think it was, and it's running glibc, which is the biggest binary that you can find. But in overall, I think we have done a good job on optimizing the size down, but still it ends up being 2 gigabytes of stuff to deploy. But when you do the Docker save routine, you are transferring these containers to a different environment. You have always Docker save that just saves the layers and everything's fine and dandy. You can save a bit space with that one. The disk usage, just to share you some of the raw stats, we have a API server load is around 200 gigabytes. Counter API load would be higher, but we have a bit of a problem with getting good disks. So it's now moderate 100 gigabits. I would like to use myself 2 terabytes. Redis is for some reason quite low this time that I took the snapshot from a staging environment. But gives you a ballpark where are we standing with this one. So at this point I want to have your opinion on CPU count. How many CPUs do you think we use for making this one full pool that I like to call it? The full pool that we read data from network, calculate the algorithms that we are running on Python, by the way. How many CPUs our cluster contains? Any suggestions? Show something, please. 500? 8? 4? Too easy task. Yeah, the 4 is what you have on your laptop, or 8. That is also doable, but takes a bit time. So 50 CPU per one instance in the ballpark. Also depends. Rules and conditions apply. So it's always, that's one instance. We are running multiple instances. We have a test setups for different use cases because we are developing parts of the system where there's a 150 CPU per one developer at some times, because we need to have a separate or own instance to test some kind of architectural project that you want to pull through. So I just, on my own curiosity, I used the AVS calculator to estimate the costs of how much it would take to run 5 times machines that have 10 CPU, 32 gigabits each, 2 terabytes of storage for 3 years. That is costing 200,000. And AVS, of course, promotes that it is 50,000, but well, that is the prices are not always what they are in the calculators. But give you a good idea. It's a quite expensive operation in long term. We are already running this several years, and will be running quite many years in the future. So what we would like to do, we are not currently running on top of Kubernetes, because we developed the environment when the Kubernetes was just released half a year ago from the 1.0 Kubernetes that was pushed out. We have our own orchestrator in place. But we would like to be on top of Kubernetes, and we like to throw in 50 CPU machines with 2000 gigabits of memory and terabytes of disk space available. We would also like to have some local contact that can handle the cluster for us, because it's always a bit tricky to have a disjoint people, the ones that are building machines and not having access to the server rooms itself. It's a kind of separation that I would like to see myself to be more closer to. So if we are going to foreign countries, we would like to have a local host for that type of cluster, because we cannot ship the data out from Finland, we cannot bring in the data from other countries that we are operating on. We are always limited to the local machine rooms. We would like to increase the utilization of our current clusters. Those 50 CPUs we have in one instance are underutilized because we cannot use the available resources in full that we have. And also because we are now transitioning on top of Kubernetes and we have an ongoing production, we cannot miss a heartbeat, or, well, we can, rules and conditions apply, but we have to keep the current production up and running with the efforts that we have. So it's always a bit of a balance. So one of the answers is always, well, OpenShift. It gives you quite much stuff. You can have a consistent development environment. There's features built in that Kubernetes is missing or are already being developed on, but are already in OpenShift. And in some cases, it's not your cluster, somebody else will be managing it for you, which is me as a developer a good thing. I don't have to care about those machines, where they are, how they are doing. I just want the resources, so I can run the algorithms. So, because of our history, we're stuck with the Docker-based homebrewed operator orchestrator. And the way we have built the environment is assuming that there is a disk locally available, which is not true if you are working with Kubernetes setup. So let's take this kind of idea a bit further. If I'm going to a customer space, they are giving me virtual machines. There I'm going to set up a Kubernetes cluster. Then I also need an external storage. I have a huge load of data that I want to be able to use in different environments of the Kubernetes, different corners of the same installation. It's not just the Kubernetes cluster I need, I also need good storage backend that can provide me with enough of disk I/O. With Kubernetes, what I have found out personally, it's the load balancing is just not there. It's just about HTTP, which is not a transport protocol. And that is my own rant. And it's good to have an external load balancer because there you can do a bit of more tricks. Or, well, we have our own solutions. We are using F5 and it works okay. Kubernetes autoscaling, if you think of, we have a huge array of, we have a big cluster. I want to be able to just set the limits and not worry about it. But the CPU limitations are not enough. I would like to make limitations a bit more versatile. So in my opinion, the ones that are now available are not ready for production. And yeah, that I have found out from the summer vacation that I came back, I started working on the cluster. Setting up your own is hard. And don't forget to thank your sysadmin if he or she does it for you. So thanks, Jesse. Future plans, these are kind of the things that we are now looking into. What would be nice to have also in our environment to use. CRI/IO, a different type of container, rocketing stuff. KOps, COPS. I think there was one presentation on Helm charts also today that is worth checking out. IST/IO, don't know about that, but our DevOps were furious about it, and it's a bit different approach to the networking problematic overall. And in our own work also, we have a quite a big thing to do to investigate the affinity problems, affinity settings, how we could use the Slack that we have running on the machines more effectively. Maybe build a learning system that sees the trends, which time different parts of the cluster are active, and adjust the minimum levels of the containers as a management operation outside from the user control. It would be really nice, because I can, with the setup that I'm running, been developing, we can take all the CPU that we have on cluster available easily. It's not, we are munching through so many different kind of calculations and data problems that it's no brainer. And references if you're interested in. So, Topa.
Yeah, last slide. So thanks for the presentation, Santeri. Give a hand for Santeri. Now, Elysians, could you stand up, please? Like Jesse and Antti and who else are here? No more? Ah, Jesse, good. If you want to talk with us about these projects that we were talking, or just any other stuff, or planning to join to work those international Kubernetes problems, talk to us or go to Elisa's webpage. Thanks.
in about 2 minutes, we're gonna start again. Okay, let's start. The next talk is due in a minute.
Can everyone hear me now? I think it sounds very loud, so that's good. So now we're moving on to the next talk, which is by me, and it's going to be managing complexity in Kubernetes with Helm. This was a very pretty slide, but unfortunately the Helm is a bit messed up, but I think everyone gets the text from there anyhow. So to start, so I'm going to talk who am I? You might be wondering, who is this random person standing here? So I'm a long-time tech and startup community enthusiast, been working there for 6 years. I am one of the Kubernetes CNCF meetup or co-organizers, might have noticed me here in the beginning of the meetup as well. I am a producer and organizer of Igloo, Conf and PolarCon, which are the biggest Azure events in the Nordics. And also with that, I'm quite active in the Finland Azure user group as well as this meetup. I'm also a co-host of Cloud Gossip podcast. It might be a bit too less technical for this audience, but if you have any non-technical people in your life that would like to learn more about technical things, it's quite a nice thing for them. And we do have an episode on containers as well, so that's neat to check out. I have worked as a marketing professional, startup coach, and so forth in companies such as UpCloud, Microsoft, HiQ, or Azure Accelerator, so quite a lot of things. but I do want to stress and give a disclaimer. So with the Helm and with the Kubernetes stuff, I'm still learning. So learning is the key, and not knowing everything and being the mastermind of the world at the moment. So, but I am quite obsessed with Marvel movies, and at the moment I'm really into Stargate, SG-1, and Atlantis as well. And who doesn't love cute dogs? So that's always good. But yeah, then to the topic at hand. So Helm, which is a package manager for Kubernetes, and as you can see here from their website, Helm is the best way to find, share, and use software built for Kubernetes. So what that does actually mean, and what is Helm? So Helm is a project maintained by CNCF, which is in collaboration with Microsoft, Google, Bitnami, and the Helm contributor community. So it started as a Kubernetes project, but it has graduated to be a standalone project in the incubating stage. So the incubating stage is the middle tier of CNCF, which is actually the most crowded of them all. So there's only 2 projects that have graduated, which is Kubernetes and Prometheus. So it's a good crowd to be in. Yeah. And then specific things for Helm 2, which is that Helm has 2 parts, a client, which is the Helm, and the server, which is the tiller. And tiller runs inside your Kubernetes cluster and manages releases, aka installations of your charts. But as always, life is always fun and not fair. So with Helm 3, everything will change. So it's going to go to a client-only architecture, but for now, this stands. Yeah. And then charge that I mentioned before, they are like, you can think of them like Kubernetes equivalent of homebrew formula, an aptitude package, or a yum RPM file, and charge are Helm packages that contain at least 2 things. Then a description of the package, or 1 or more templates, which then contain Kubernetes manifest files and whatnot. And charts can be stored on disk or fetched from remote chart repositories. And then really Helm is quite nice because it really helps you manage complexity, easy updating, simple sharing, and you can use Helm to roll back to older versions of your release with ease. So really, in a nutshell, Helm makes your life a lot easier. So, who here likes writing Docker files? Oh, few people. Ah, that's surprising. Well, then this might not be for you, but that's surprising, but cool. Some people like pain, it's okay. So what I would like to see is why not let machines do it for you. So time for a really quick and easy demo, which is easily deploy complex application, which is in this case WordPress, to Kubernetes using a Helm chart. So if we end the show and go here, we'll see in here that we can do yeah, I didn't even see that. Yeah, resizing. If we do that there, we can see that there is Azure is happening, and I'm logged in there. And yeah, I'm making it happen. There we go. Is it good now? I can do a bit. So okay, starting to look quite yeah, but it's messing with my OCD a bit with this being not yeah, that's good, that's better. So if we do this, then we see that we have there's an empty Kubernetes cluster running in Azure, but I created it on Sunday, so it's 2 days old, which is very nice. And then if we do this, then we see that there are no Helm releases either happening. So this is a very clean slate to work with. So then, yeah, I'm, by the way, really bad with typing and typos, so bear with me while I write. It's always... so... There we go. And then we can see that there is a WordPress chart available in the Helm stable repository. And then if we do this, yeah. Oh God, thank you. This is yeah. So now we have a nice goodly tiger happening there, and as you can see in here, we have the cluster and the cloud, the MariaDB and the WordPress happening, but the external IP is still pending. So we cannot get to the website quite yet. So we can actually see now another neat thing about this. So in here that you see that there is the password things. So you can actually really easily just see your password if you go here and do this. So there you can see that it's super easy to get, which is it under the pink? Oh my God. So if we move here, yes, there you see the password. Very pretty. Yeah. Yeah. Or I can do, I don't know. Yeah, well, can everyone see it now, or do I press a few more enters? Now at least. But yeah, good. So, but yeah. So, then we can actually see if it's is it still pending? It is happening, but I don't think it's up yet, so yeah, no, but I have actually other things I'm going to speak through here, so that's why I was actually checking that it's not there. So, first we can actually go here because I have another slides while we wait, because it's kind of usually take 6 to 7 minutes even, so I was prepared for this. So now that we wait for that to happening, so installing Helm, what do you need? If you're now super excited about getting it, if you want to avoid the Docker files, but let's see. So if you're using a package manager, you can use Homebrew, Snap, or Chocolatey. Or if you're doing manual installs, then you can download binaries from GitHub. And then after that, what do you do then? After running Helm init to initialize Helm client and tiller to your running Kubernetes cluster, so it will also set up any necessary local configuration. And do note that you need to have a running Kubernetes cluster and kubectl setup. So depending on your setup, permission changes for your Kubernetes installation might be needed. And I'll be putting all of these slides, by the way, to SlideShare, so that's why there's a lot of information there, so if anyone wants to see them there. So, and after you're done with these steps, this is how it should look like, which is success, and then everyone can pat themselves on the back and be happy and joyful for the rest of their lives. And here is a few first Helm commands that you might have some of them be seen already. So if you want to search for chart, you can use Helm search, or if you want to download a chart to your local directory to view, you can use Helm fetch. Or if you want to upload the chart to Kubernetes, then Helm install, and list releases of charts with Helm list. So then we can actually now go see if it's ready yet. let's hope that it would be. Let's try it out to see. I have this nice incognito here. I doubt that it's ready yet. Yeah, but then in the meanwhile, we can go check out some other things. Let's leave that to ponder for a while there. So, if you use this, we can see that there has actually been 2 restarts already. So, it's trying its best. It's not visible again. Yeah. Yeah. Yeah, well, I'm sorry. My screen is looking good, so it's easy to forget. I'm sorry. But keep reminding me if I forget. Yeah, and then if you want to actually, I think we'll open a new window for this. In here you can see that if you use yeah. Helm inspect. So now you see that there's a lot of information, like a lot of it that you can see. And in here you can see that it's been Bitnami, made by Bitnami, and you can see all the nice information in here, which is very neat, and you can keep on checking these. But let's see if it's now happening. Well, it probably should be by now, because it is so old already. If the internet forbids. Not yet. Yes, now it's here, guys. Very exciting. As you can see, it's up and running. Very little work, but a bit of time waiting for it at least. But that's, life. So if we go here, I can actually show you that it's very nicely. The password, where is it again? Yeah. Down, down. Yes. Yeah. Yeah, it's there. Yes, so we can even go in with the password there. Yeah, so that's it. Very nice. I think that was very neat. Hopefully someone learned something. Very good. Thank you for everyone. Yeah, so do we take now a couple minutes for the next speaker to get ready?
Yeah, we could do so.
Yeah.
Maybe.
Testi 1, 2, 1, 2. Testi, jep.
Okay, can you hear me? Yeah. So the next speaker is Jadar from Kubik, and he's going to talk about Kubernetes security, which is a really interesting topic. It's very common that when you are excited about Kubernetes, you go install it, do everything, start deploying applications, and then you notice that all your business logic is exposed to the world freely without authentication. So a really needed talk. Looking forward to it.
Thank you. Thank you, Lucas. And thank you for having me. So as you know, my name is Jerry. I'm from a company called Quick. I work there as a senior system architect and responsible for different deployments for our clients, infrastructure decision designing and all of that. But today I'm representing this more of the community side as a Google developer expert for Google Cloud. I'm gonna give you a talk. Oh yeah, let's do this before we continue, because otherwise we're gonna have that constantly. So a quick recap of my things to do before displaying. Turn off the screensaver with password. Run never. There we go. Okay, continue. So security journey, that's my goal today, is to bring you forward to the current state of your security and what you still need to do on it. Let's see if we can hit that milestone. A little bit of the agenda. Let's do an audience introduction first. History of Docker, where is Docker now? History of Kubernetes, where is Kubernetes now? What does the security mean? Who should I contact about my security needs? Just kidding, we're not going to do any of that. I believe that every single one of you that are here in this room knows something about Kubernetes and containers already, so I'm not going to spend your time to go through those. But first of all, let's concentrate on the topic itself, so the security side. Security on containers compared to the virtual machines and on the history of ones are a bit different. So let's see some of these fundamental differences between containers or in containers. They are short-lived. You usually deploy containers often, frequently. So you are constantly basically patching them. Compared to the virtual machines, you're not normally tearing down your virtual machines every single time of day or every single deployment. You're instead deploying to do it many times, and then you can get behind of those security updates. Immutable. So you are in charge of what is actually inside it, or you should be in charge. There are cases where you are not, but you should be in charge of what is going to your environment and what is not. And sandboxing is a really difficult, really important thing. That this is something that not many people actually consider when they're running containers. They believe that they are already constrained by that container runtime away from their hosts. Unfortunately, this is not true. It's you need something more sandboxing if you're really security constrained. And there's this new project from Google, something like gvisor would help you a lot on this. We're going to talk more about this later on. And with Kubernetes or with Docker itself, or with playing with containers, usually good security practices come with just a one-line chains. So you don't really need to be like really professional around security to be able to enable those security best practices. So, few more differences between these two, VMs and containers. The surface of attack. In a container, you usually run a minimal OS. So you don't have the full-fledged of the kernel and all of that inside your containers. So your attack vector is, of course, a much more smaller. Resource isolations. You have namespaces, C groups, and all these already working for you when you're dealing with containers. So you are not that exposed by your host system, or you don't expose your host system that much. But still, there is ways to get around that. Permissions. Again, access controls are for privileges and shared resources. So you don't really have this kind of a root use. Yes, there's a question already. Yes. Yes, and that's basically what it. Yeah. That's definitely true. So in a best case scenario, you don't have anything there. You just have your application. You just have a scratch Docker base, and that your application. That's it. That's the best like standing point. But the main point is the difference between VM. In a VM, you cannot go that. You have always the full-fledged of that host system and all of that. So in Docker, no. So that was the difference point in there. But you're correct. You don't need any kind of a host OS inside a Docker. Lifetime. Containers have a really short lifetime. Usually. At least they should. They should be teared down, constantly monitored, rebuilt, patched, and this kind of thing, either automatically or by you. And there's actually a Systek, Systek has estimated that 95% of containers that are running in the wild live less than a week. So if you are on that 5%, go ahead and move over to that 95% and what everybody else is doing. Now, I wanted to talk about first of the thinking, how do we approach this kind of a security issues? There's a lot of different topics that we would need to go through. Unfortunately, even a week isn't enough to cover every single detail, but we're going to try to ramp this up quickly enough. I'm going to break down things a few of these simple containers of these simple tasks. So we have privilege escalation. Somebody steals your Kubernetes API credentials. That's pretty bad. After that, they have full control of your Kubernetes environment or other credential depths and all of that. Unpatched vulnerability. This is something that your developers might do without you as a DevOps or SecOps even noticing. The code that actually gets deployed is already vulnerable. So this is something that you need to mitigate against also, or think about. Like these zero-day exploits in some common library. And then thirdly, this kind of a DDoS, the node compromises. Not just the whole cluster, but a node. Either through a vulnerable container engine or vulnerable Docker container, your node gets compromised and starts mining Bitcoin or something like that. This is something that you don't want to happen. And also, when you usually when you set up a Kubernetes cluster, your nodes might also be public. So your node IPs might be public. So remember to protect them from that. So breaking these down to the topics of today, more or less, we're going to talk about infrastructure security. Is your infrastructure secure for actually developing and running containers? And this topic includes where are my secrets? Are the secrets secure? Where are my credentials? Are they on a GitHub to everybody to read on and act on? Or are they somewhere safe? Software supply chain. Do I actually trust the thing that went to my cluster? Do I actually know that it was built either my developer or from our CI system? How do I make sure that what is running there is something that is meant to run there and not something else that looks similar but isn't? And then the runtime security. So you trust your developers? I wouldn't. So never ever trust anyone is my kind of a way of thinking, not even myself. So that's one way of doing it. Making things so that even the runtime, whatever gets run there, cannot really do more than they were supposed to do. That's one way of thinking of it, in my opinion. And then, of course, there's the application security, like the 7 factors, 12 factors, 14 factors, however you want to use them. Security requirements for your application itself, whether it actually is publicly exposed or just internal application development. And then the platform security. Is your platform secure enough? Is either cloud platform or your on-premise? Who has access to your on-premise data centers? Who can take out your disks where all your secrets are? Unencrypted, probably. So these kind of things. So Kubernetes is only one part of your security journey. You have the application, the virtual machine, bare metal, whatever is running on underneath, running the nodes. So Kubernetes is just one piece of it. And inside Kubernetes are the containers, which are, again, just one piece of it. Kubernetes has done a lot of good job on protecting you already on a different vectors. So you already have different kind of logging, monitoring available for you. So you can actually see what your containers are doing. Then you have debugging and introspection. So you can actually attach to a container, or you can just run it locally, test what's happening inside. And then you have identity and authorization. And one great thing about Kubernetes is that it's actually separated. So you have separated identity system and separated authorization system. You can think of it that you have your passport and then you have a visa. You go to a new country, you show your password, proof that you are who you are, and then you have your visa to say whatever you can actually go in or stay there. So that is a really good thing, and everything is pluggable, as you know, in Kubernetes, so you can do quite a lot of things with these. A simplified Kubernetes. I promised I wouldn't go too deep on Kubernetes, but I want to dive through these simple mentions of Kubernetes architecture, or simple things on Kubernetes architecture. First of all, we have the cluster. And the cluster is the basic set where all the nodes reside in. From that on, we get to the node. So we have a X amount of nodes in our cluster. These talk to the master and the machines that run your containers. So your containers live inside the nodes. Again, something that you all know. A container lives inside a pod. Pods are the collection of those containers. And then you have your master. And then you have your etcd that's used to store all the dates and everything basically about your cluster. Everything that defines your cluster stored there. So let's take a peek what happens when an attacker gets hold of different things. If an attacker gets in control of your container, or basically inside your container, compromises it, they might be able to escape it, escape the restrictions that you might believe that are in place to ever prohibit anyone from getting from a container to the host. That's not true. They might actually be able to do that. They could compromise the node. So what happens when they compromise the node? They might be able to attack the master or just abuse the compute. That's usually the case. So they put the compute to actually run Bitcoin mining or any kind of cryptocurrency mining for that matter. Well, if they are already on your master, that's pretty much it already. Also, if they take control of your etcd cluster or etcd instance, depending how bravely you want to live, they are in control of your cluster state. So thus again, in control of your cluster. So always encrypt your etcd. So needless to say, when they are in the master or etcd, they pretty much already own you. So let's take a look of today's security journey that I want to take you through. to just make sure that we are at least on the same level, on the basic level of security whenever dealing with Kubernetes and with containers. So we're going to follow on these few maturity steps that you can also evolve later on with your own environments. So we're going to begin with setting up the cluster right. There's a lot of different things, moving parts, but here are some of the highlights. First of all, you want to restrict, or you want to really restrict who has access to your kubectl. So basically, who has access to your API server, Kubernetes API endpoint. Then you definitely want to use RBAC, so the role-based access control, again, in comparison to the ABAC. Then you want to use network policy. This is something that I won't say that you always need, but definitely should do. It brings a lot of good parts. Use namespaces. This is again, this is something that you can decide yourselves. But bootstrap TLS, so everything TLS inside Kubernetes cluster, especially if you're setting your Kubernetes cluster up yourself, make sure that everything runs in secured communication. Then we can follow up to the next step, which is this kind of a security hygiene. Hygiene can be from different kind of perspectives, whether you are financial sector, healthcare sector, or you're banking. You have different kind of needs and different kind of fears of what might be happening to you, what kind of attack, what kind of people are attacking you and your deployments. So following these rules, keeping your Kubernetes up to date. Inside those Kubernetes nodes and the master, use minimal OS that has been less known for a wide range of security holes, especially on the kernel side. Minimal identity access management roles. Well, this is more related to the cloud kind of a way of thinking. Private IPs on your nodes, so don't necessarily publish your nodes to the public if not necessary. Monitor access with audit logging, verify binaries that are deployed. Prevent known attacks, disable the dashboard, disable the default service account tokens, protect node metadata, scan images for known vulnerabilities. Then we can go on and go on and on. This green light basically can go as long forward as you want. But here I just wanted to highlight a few. Let's use port security policy, preferably, and protect our secrets. Those are the minimum things that you should do. And then there's something like considering the sandboxing, limiting the identities, service mesh like Istio for authentication and encryption, transport control, all of that. So let's take us to the journey. We have limited time, so I hope to run through these parts. So we're going to focus on restricting access to kubectl or kubectl or kubecontrol, whatever you want to call it. It has many names. Using the RBAC, user network policy, dashboard, service account tokens, and port security policy. So these are our goals for today. Let's see if we can run through them. Oh, I've resetted my clock. Well, no, it's the best guess of how long I've already spoken. Hopefully you'll bear with me. So getting started. Let's see. If we can get something going on. There we go. Almost, almost. There we go. Well, I'll use this then. There we go. So restrict access to kubectl, kubectl, kubecontrol. Use RBAC. We're going to use a network policy. Protect kube dashboard. Disable account token, and use a port security policy. So these are our goals. Let's start. As I am a Google developer expert and Google developer kind of an advocate in that sense, I'm going to talk about the separation between these two. So Kubernetes, raw Kubernetes at itself, and Google Container Engine, where I always run our production clusters. Been running happily nearly 3 years. So Kubernetes is a lovely piece of art that actually works brilliantly. So restricting access to kubecontrol, kubectl, kubectl, whatever. Let's decide a name for now. Who likes, what do you use for the name? kubectl, easy enough. Let's go with that. So never again need to worry about that. So again, if an attacker command can run your commands against your cluster, it pretty much they own your cluster if you don't have RBAC enabled and all that, so forth. So on raw Kubernetes, how do we fix this? One way is to enforce a bastion model via firewall. So with the bastion model, it's basically you have this kind of a bastion host or virtual machine or any kind of a host that is only allowed to communicate towards your Kubernetes endpoint, API endpoint. So that's locked with firewall. So no matter who the developer are, if they don't have access to the bastion host, they don't have access to your communicate with kubectl towards your control plane. In Google Cloud Platform firewall definitions, it would look something like this. So we would have a firewall that only allows 6443 from SSH Bastion or any host that has a tag SSH Bastion with that range, kind of an internal network range towards any node that has a Kubernetes controller tag. So again, this is not related anything to Google Container Engine. That's a different story, but a raw Kubernetes installed on top of VMs. So this is how you would do that. But again, different cloud hosts, different firewall engines and firewall restrictions would look a bit different, but the idea is the same. So how about in a Google Container Engine? How to restrict this access? It has a few features that you can enable. Authorized networks. This allows you to define up to 20 networks, that is network ranges, CIDR ranges that are actually allowed to communicate towards your control plane, the kubectl API server. And private clusters also related to this. They can, with this feature, you can restrict the access to all the nodes, so none of the nodes have public IP addresses at all. So these two features, both of them are still in beta, so they are not in general availability. Everybody can use them, but they don't have any SLAs currently, but should be there soon enough. And there's the links to the documentation of that. I'll share the slides later on and link it to the meetup group. Then, using RBAC, role-based access control. So, setting permission on individual resources, defining roles based on their use cases, and so forth. I would always suggest to go with the least privilege principle. So basically don't trust anyone and give them only the minimum requirement roles or permissions that they would need for to finish their job or to complete their job. There are 4 top level types. To those who RBAC is new, I'm going to just quickly cover up what RBAC means inside Kubernetes. So you have top level types, 4 of them. You have roles, which are namespace permissions representations. Cluster roles, which are cluster-wide representation of those permissions. Then you have role binding, so you can bind some subject to some role inside a namespace. And then you have cluster role binding, which can grant, I'm sorry, they are all the way in the bottom. Again, that was bad on my behalf of designing the slides. But you have role binding and cluster role binding. So, you can also use the kubectl command to test those roles. Once you've given someone a role binding or cluster role binding, you can ask the kubectl whether that particular user can execute something. Like here, I can test if this user, whatever email or service account email I would have there, can actually create secrets. It would return to me yes, or then no, needs this and this permission. So it would inform me what kind of permission is missing from that particular user account or group or service account that actually I need to set before they can execute this particular command. And when using Kubernetes, you can enable it on a creation time to a new cluster with the authorization mode RBAC. So disabling the ABAC and taking on with the RBAC. And here are some examples. There's a role and there's a cluster role. So on this role, of course it's a TV that doesn't recognize the the pinpoint, but basically there's a role that specifies this kind of a permissions to read pods. So anyone who has this role through role binding can read pod in a namespace given by that role binding, and also read that pod's logs. So the resources actually follow through the API paths that you have on a Kubernetes API, and the verbs is basically get, put, post, delete, watch, list. Pretty much those are the verbs. And then we have the role binding and cluster role bindings. They are the same thing. This is actually showing 2 role bindings and not cluster role binding, but demoing that here we can use a role on the right side. On your left side, you will see that we will give you we'll give this user Jer a read pods permission inside a default namespace. And here we have defined a cluster role, so not a role, but cluster role called secret reader from the previous slide, and we still give that cluster role to a namespace. So you can mix and match that. You can have cluster roles, cluster-wide permission lists, but you can give them namespaced with the role binding. That's just the goal. You can read more on that later. We will not have enough time to cover them thoroughly. Then on Google Container Engine, you can use the RBAC normally, and in top of with IAM, it's really helpful. And you can use the IAM to manage your users and permissions at the Google Cloud project level. Use the RBAC at the cluster and namespace level to set permissions. There's also a custom role that you can create inside Google Cloud IAM. I'm not going to go too deep on these because these are really Google Cloud specific. And then you can have, you always must, when you create a project, when you ever create a cluster, you have to set yourself, no matter whether it's your own cluster or Google Container Engine cluster, you have to set yourselves as a cluster admin when you have RBAC enabled. Otherwise, you cannot execute any other commands basically in there or create any of these rules. That's about that. Network policy. So, as you know, everything in Kubernetes, when you deploy pods, they can discover each other and talk to each other no matter what. Pretty much, they can discover their names by the service. They can communicate whatever network protocol you want. They can do that. But with network policy, you can make them isolated. So if you define a network policy that says this pod can only talk to this pod, then these pods can only talk with each other. Well, basically this pod can only talk to that pod and nothing else. Or if you say that only requests that come from ingress that has this header can actually reach this engine's deployment. So you can do these kind of things, completely isolate your pods and containers from each other and from the world. As a policy types, you can set ingress, egress, or both. Defaults to ingress. You will then define whitelist rules of these policy types. Following selectors available: IP block, namespace selector, pod selector, so forth. Oh, these 3, not so forth. Here's some examples. This is a really simple network policy where you deny any traffic. So when you apply this to your cluster, to your namespace, nothing that is in there can actually communicate with each other. So no DNS, no discovery, nothing, no communication whatsoever can happen between pods. And then here we can define that any pod, basically that matches labels run equals nginx, are allowed ingress from any pod that has label access equals true. So you have a pod that has label run nginx, and then you have another pod that has labels access true. These two can communicate, or this one can communicate towards your nginx, but none other pod can communicate towards your nginx. Yes? You can set it on cluster level or namespace. Oh, actually namespace only. Yeah, sorry. But basically, yeah. So if you do that deny rule in the beginning, if you do that, one thing that you want to most likely do is enable the DNS still, so that the discovery works. So with this rule, you can apply this to all the namespaces that you have in your cluster. It will allow anything to communicate by protocol UDP to port 53 in the any pod that is in kube system, and communicates with that. So with these kind of things, you can do different logics. Using a network policy in Google Container Engine, when you create a cluster, you can enable it with a flag, enable network policy. Currently, it supports the project Calico from Jira. And then we are off to the next topic. So, protecting your dashboard. You might remember this kind of a dashboard. How many of you use actually this Kube dashboard? Pretty many. A bit over 10%. That's scary. Well, let's move forward. So, Kubernetes dashboard. Why should I disable it? Now it's my time to prove to you why should you disable it. So, Tesla Kube dashboard was hacked. This is one good example of those kind of things that might happen. Even though that if you're a big company, you have a massive amount of money and brilliant developers, these things can still happen. So hackers access the Kubernetes console. It was a default deployment to AWS, the Kubernetes cluster deployment. From that, it actually gets completely unprotected public IP address based Kube dashboard, where you can go in, have the secrets, so you can get all the AWS credentials, and then do whatever you want in that AWS project. So, don't leave it open, at least. And Tesla is not the only one. Like Aviva, Gemalto, both multi-billion-dollar, national projects got hacked the same way. And there are estimates that over 20,000 Kube dashboards are currently vulnerable, open in the internet, and over 300 of those have no security at all, no password, no authentication. Yes? Sorry? Yes. Yeah, that was one of the reasons. It was public and not protection at all. And this is the default when you actually it used to be the default when you deployed Kube, that it has no security whatsoever. I'm gonna get back to it. I'm gonna get back to that. So, first thing that you're gonna do, have any kind of security on it. Just literally any kind of security on top of the publicly front-ending dashboard. Then there's these few extreme measures, like simple fixing it is the lazy way. Don't deploy it at all. Just completely get rid of it. This is what many people do, and many major organizations actually do. Just get rid of it. Then you can reduce its permissions because it's running on the default service account, which has master access to your cluster, so it can actually do anything. What you can do is run it on a separate or different service account and change those permissions to only, let's say, viewer roles. So you can just only do viewing from that Kube dashboard. And then you can reduce its permission and add authentication. Then you should be pretty much okay. And you can, of course, not expose it to public internet at all and just use proxying to get to it. Yes? Yeah. There we go. Well, basically this is a GKE, but yes, on the latest versions of Kubernetes itself, it's not even there. And with the Google Container Engine with 1.7 clusters, they don't have any admin access. They have these read-only accesses. And from 1.10, there's no Kube dashboard whatsoever at all deployed there. So if you want it, you must manually deploy it and configure it. The reason for that is that there's really no need of Kube dashboard whenever you're running in Google Container Engine, because you have much better and much more powerful this kind of a dashboard in the Google Cloud Console itself for Kubernetes. It's just a rule of how to get rid of it if you already have it, but that's... Then account token. Now this is a different topic again, but every namespace, as you know, has their different Kubernetes service account. And these ports, whenever you set up a port to that namespace, actually gets that service account, mounts its secrets, and then with those secrets they can call to the Kubernetes APIs that are available for that service account. And usually by default, that service account actually has pretty loose restrictions, so it can do pretty much everything. So if you don't specify a service account when you create a pod, it will default to assign the namespace service account. So by default, it always has a service account if you don't do anything else to it. Now the pod, as I mentioned, mounts these credentials and then can access the Kubernetes API. So these credentials can be used to perform all different things against the API that the service account has permissions to. You can. Yeah, I'm gonna get to that. Good point. So this is the way when you have your custom service accounts that you can set this flag auto-mount service account token to false, so those pods won't automatically get these service account credentials mounted to them. And it's disabled by default when RBAC is enabled. So from Kubernetes 1.8 up. So if you have an older cluster, then you have to fix that first. Then on Google Container Engine, the default service has no privileges if ABAC is disabled. RBAC is enabled by default from Kubernetes cluster 1.8 and up. And well, that's it. So it's pretty much integrated already, so you don't need to worry about it in Google Container Engine. Then, last but not least, using the pod security policy. So with this one, we get to that container restrictions and all of that. So we have few options here. So some basically kind of these Linux security constructs. So we have AppArmor. It's the security model that lets you restrict what your program can do and cannot do. Various and out processes, file functions, read, write, execute, so forth. Then we have the seccomp, which filters processes to these syscalls for you. Basically, it also limits what you can do and what you cannot do in terms of syscalls. Push the application in the secure whitelist state. Docker seccomp automatically already reduces this vulnerability scapes a lot, so it automatically denies over approximately 150 uncommon and not so critical syscalls, like mounting from inside the Docker. You cannot really unmount your file system without explicitly giving it seccomp access to those syscalls. So, few different things: security context versus security policy. So here we have a this kind of a graph called a single pod and all pods in a cluster. So in single pod, we have these Linux security constructs which we want to use: AppArmor, seccomp, run as non-root, etc. All these kind of policies. We define them for single pod. We define them in the security contexts, which in this case means inside your YAML file for that pod or deployment spec, whatever you are doing. These are deployed in the security contexts, and that is the YAML file for that pod or for that deployment. And they are enforced at runtime. So when it actually gets up and running, those rules are enforced at that single point of time. Now, if you want to apply these rules to all of your pods, you use pod security policy. And this is a part of this, basically the pod specification, but on a separate file. And this is enforced at creation time. So whenever something spins up, a new pod, new deployment in your cluster, you have defined your pod security policies to your cluster. If they don't match those, they will get killed off in the creation time, so before they actually can execute anything. So this is a good differentiation between security context and the security policy. So first, in a raw Kubernetes, make sure that the admission controller is enabled. To use these pod security policies, you need the admission controller for that. So the pod security policy, we're going to enable that in the Kube API server. Then you can use this restricted policy as a good base point. This is just a snippet of that policy. You can find it online from GitHub, an example, or from Kubernetes documentation, and then you can modify it as you need. Here we just specify a few things. So this is basically from the restricted. We specify that none of the pods or containers are allowed to run in privileged mode, and they are not allowed to escalate their privileges. They must always run as non-root, so some other user than root. And also it must run, well, these basically two complement each other. Run as, must run as non-root, then supplement all groups. So we define that it can only run as a user that ID starts from 1 to 65,535. So no 0 or this, so we cannot get to the root range. In the Google Container Engine, when you create a cluster, you can just enable the pod security policy, but you must also pass a policy if you create a cluster this way when you create it. Otherwise, your cluster is going to be empty, so no kubedns, nothing, because by default it will assume the empty policy, so nothing gets deployed. No Kubernetes, any helper or any of these kind of utilities gets deployed because, well, there's a policy that defines that nothing can actually go in. So, recap. Getting started on your security road, at least do these parts, or those that actually are close to you are really necessary, but I find these are really simple to implement and doesn't really take that much effort from your side, but are really, really good for your overall security journey. Then there's a lot of different things. I've marked here with the Google Container Engine logo all of those that you get out for free whenever you're using Google Container Engine. So it does a lot of security for you already. It has automated updates, automatic security updates. You don't ever have to restart your cluster to actually get those security updates, because the OS that's actually in those nodes is a custom container optimized operating system based on Chromium OS, which means that Google can actually apply security patches even to the kernel on a running machine just like that. So you don't have to worry about that. It also supports auto-scaling, horizontal auto-scaling, pod scaling, node scaling, security updates, Kubernetes updates, all of these. So it keeps the Kubernetes up to date for you. Again, something that you don't need to worry about. Then you have the verify binaries that are deployed. Make sure that you have some kind of, well, you can use open source tools. A lot of open source tools offer these kind of features and scan images for known vulnerabilities, like Claire does that for you. There's some few other tools, open source world also, that does for you. In GCP, you can use cloud build, binary authorization, and then this container scanner that automatically implemented in your pipeline that makes sure that nothing than your approved containers actually run. Then protect your secrets any means necessary. There are different ways of doing that. And then limit the identity used by pods. There's currently an open source proposal in GitHub from Kubernetes side. Take a look at that. Consider voting and taking action on that. And then the gvisor, I definitely suggest you taking a look what it can do, but it can protect you against different kind of attacks against your hosts wherever you are running your containers. So either raw Docker, Kubernetes, whatsoever. To learn more, there's from a Kubernetes engine perspective, there's the security overview and hardening your cluster for production environments. Then a really good read that actually has Lucas's graphs also inside it is from Kubernetes blog, 11 ways to not get hacked. It's something that everybody should read when you're running on Kubernetes. Thank you. That's from me. Thank you so much for listening. Hopefully it was somewhat learning.
Thank you, Jere. Okay, so next up we have some folks from Red Hat and talking about OpenShift and building a distribution of Kubernetes. Like we saw Google's here. Google have their own distribution of Kubernetes, adding some like security features running on their cloud, etc. Building stuff in for you automatically. Red Hat does the same thing, and it's also open source. And now we're going to talk about the challenges and ways to build such a distribution. Feel free to grab some more beer or whatever in the time being. We'll have a pause of like 4 or 5 minutes in order to set up AV.
Now it's on. Okay. Hey, hey, hey.
Okay, in 1 minute we ought to start. So. Okay. So now the next talk is about OpenShift and building a Kubernetes distribution. Kubernetes distributions are important in the ecosystem. We have the vanilla code and everything, but for different customers, or different customers have different needs. Some people want it more opinionated and with more features. And some people just want the raw syscalls to Kubernetes they can use to have the greatest power of all time over the machines. And while building a Kubernetes distribution, you have to do a lot of trade-offs, but it's also very important to contribute what you've learned in your distribution back to the community. And here's a talk about how Red Hat does that.
Hello, can you hear me now? Okay, good. So my name is Marek. I work at Red Hat in the OpenShift team, and today I would like to share with you some information how we build or how we approach the process of building OpenShift and OpenShift Origin, which is now called OKD, which I have on the other slide. OKD is the upstream project for OpenShift. Have you heard about OpenShift already? Okay, everyone. Wow, that's nice. Thank you. So OpenShift Container Platform is our product, and we had OpenShift Origin, which was renamed to OKD. So OKD is the upstream project where all the work happened. We are pretty much upstream first, so everything is happening on GitHub in the public. So if you go to github.com/OpenShift/Origin, you can see all the process, all the code, everything that's there, that's coming in the next release is happening there. So it's not like we are doing something in the back and then releasing it out in the open. We are doing everything in the open, and then we are stabilizing or like snapshotting the code we have in there in the project into the product. So there is a bunch of different technologies that come into OKD, and then from OKD, 3 products are built. Container Platform is an on-premise product that you run yourself. Dedicated is run by Red Hat for you as a service, and it's single tenant. OpenShift Online is multi-tenant, where it's like Heroku style, everybody running on the same cluster, right? So there are 3 different products, but today I want to focus on the OKD and the things that we do in our relationship with the upstream Kubernetes community. So, as I said, we are working not only in the OpenShift Origin repo, but we are working very much in the upstream. We have more than 200, I think, individuals in Red Hat contributing to Kubernetes. And we are second contributor after Google to the code base. Some statistics were saying that we are the first. Depends if you count the lines, counts the commits, counts the number of people, etc., etc. If you choose different metrics, there may be different outputs, but essentially Google is the main driver, right? And we have been second after Google. What we see as very important is participation in the special interest groups, right? So anyone here is part of SIGs 6? Cool. Somebody leading a SIG? Cool. So we have both. We have a lot of people who are just participating, but we also have the chairs and the co-chairs in the SIGs. Sorry? For okay. So this is something that's very important, because when we are trying to do something, we can share the plans, we can share the ideas with the community and make it happen inside the project, which I will get to in different slides, why it's important and why it wasn't that much possible before, and what consequences it had for us. However, the result of that is upstreaming features. We have been creating features, and now we are trying to put them, we don't have to, but we want to put them into the upstream, and this makes a schism and also some challenges that's there. And then there are Kubernetes approver status, right? So the more people you have that can approve, the more power you have, however also the more responsibility you have. What's important probably is that you don't want to have one company or one organization being able to take unilateral decision about some behavior somewhere. So the more people have the approver status, the more spread the consensus can be, and the more governance can be over the product. Yeah. So there are two challenges that we have been facing, and that was that we had features that the upstream hasn't been ready yet for, which I see as the correct statement. Somebody would say, well, it's not like ready yet for, we just didn't want it at the time. But now it's there, so like in the future it's shown that those features have been adopted, but when we were saying 2-3 years ago, we should put this into Kubernetes, the community was saying, no, this doesn't fit into Kubernetes, but eventually it happened. But on the other hand, there are features that are specific to distributions. So if you have a, well, by definition, Kubernetes is a project for running containers, right? Who agrees? Who thinks that it should be a project for building containers, or that the build process and the whole thing should be part of the upstream, the Kubernetes as a core? Or does it fit into the distribution, and that should be opinionated based on the vendor? Who agrees with that? Who doesn't agree? Who doesn't care? All the rest. Yeah. So I say that, like, when we are speaking about ingress, when we are speaking about deployments, that has been something that we have been doing, but was upstream. But regarding builds, doesn't have to be like that. That's a feature that very well can be in a distribution and doesn't have to be in the core. But it's also always matter of opinion. So one of the biggest challenges is the release management. Kubernetes goes out every no, 3 months, right? Every 3 months there is a release. We do release also OpenShift every 3 months, but we are always one version behind. So essentially, when Kubernetes is releasing 1.11, we will be releasing 1.10, because we take those 3 months to do hardening, to put all these features into in there, to merge stuff that we have outside of the tree, and there is a lot of work that has to happen. There are some statistics that you can find on blog.openshift.com they did statistics how many bugs have been closed in those 3 months after Kubernetes release, before the OpenShift release. So somebody says that you always want to have latest greatest, and you always want to have once Kubernetes is released, I want to have it running. That's cool. Like, if you can afford it, if you have the knowledge, if you have everything there, it's a good thing. However, most people may benefit from being one version behind, and many distributions, even Google distribution, is released like 2 months after the Kubernetes release. So they also do hardening, they also do put the features there. So it makes sense to not be always on the latest greatest. It sometimes makes sense to just be a bit behind, just 2 months. Come on, that's not such a bad time. And then we have the OpenShift container platform, which is supported for 5 years, plus 2 years of extended support. I wanted to spend more time on this, but my colleague has written a blog post about it. So it will be published on blog.openshift.com. I want to spoil it for him. So I will not spend much time on this slide, but move to the other challenges. And if you are interested, just go in a few days to blog.openshift.com. There is a long text of how this process works, how the release cycles are done, and what we do in this regard. So the extensibility of the platform. So that's the features that haven't yet been accepted by the upstream, as I was defining it. So we created deployment configs, and we created routes. This is the two most obvious ones. However, 2 years after that, Kubernetes got deployments and ingress, right? Essentially the same feature, essentially doing the same thing, just when we were saying we want to do this in the core, Kubernetes was saying, no, it doesn't fit here. We don't need it. And then it happened, right? So what was happening now for us is that we have the duality of the resources. So in OpenShift, you can use deployments and deployment configs. You can use routes and ingress. and you need to choose which one of those you want to do. So this is why we want to do an upstream, do as much as possible in the upstream, and also upstream features into the core, because it doesn't make sense to confuse people. Like, this is confusion, right? If you have to choose like routes or ingress, they say that and they say that, like, which one should I choose? So this is a bit challenging. This is one of the challenges that we have been facing a lot in the years. But on the other hand, Kubernetes has been adding features that allow much easier extensibility, because at the time we really had to hard code everything into the code base. So we essentially take to the code base, we put our patches on top of that. When the new feature, when the new version of Kubernetes has been released, we took our patches and reapplied that on the new version, and there was the rebasing time took a lot of effort. So that was pain. So now we have custom resource definition, CRDs. We will have aggregated API servers. We have different clients. So a lot of things can be easily done in a more extensible, out of the core way, right? So if we would be today creating something, it will be a CRD that may eventually be put back into the core if it makes sense. But at the time, those things have not been there. So we had to really put everything into our core, and now we are stuck in the core with that we are supporting for a few years. Yeah. However, there is Kubernetes Conformance program. So this is the certification that this thing that Red Hat built is behaving like upstream Kubernetes. That's what we run as part of our test suite. So everything that's being committed into our project, it has to always conform to that. We have extended features, but the base features have always to be compatible with the upstream Kubernetes. Multi-tenancy, another feature that I think really takes its own slide, because especially after your presentation, you were just describing all the RBACs and all the things about that. We have seen that multi-tenancy, RBAC, and authorization, authentication has to be there from the day one. So that was one of the things that we built directly into OpenShift. And now we are upstreaming into Kubernetes. So RBAC in the 110 was put there as the GA. So that was partial, like most of the things have been put out from OpenShift into the upstream Kubernetes. And we are moving other things there. When you create a namespace, you don't get pre-created so many service accounts. You don't get pre-create policies and other stuff. So we call it self-provisioning. So whenever you create a namespace, we call it project. We create a lot of stuff around RBAC so that every project can be isolated and the resources are there. You don't have to do it manually because this can be templated most of the time. So this is also one of the things we would like to upstream, because that makes things simpler and easier to reason about. If you are just spinning up a new namespace, you get everything there. You don't have to create it manually. Challenges for customers, again, with the presentation today about Helm that we have seen. Helm has a tiller, right? And tiller needs almost all access into the cluster. So by default, our policies has been restricting tiller, so Helm wasn't as easy to run on OpenShift as it could be, because we were restricting all the features, all the things tiller wanted to do into one specific namespace. So like a global tiller didn't work well. It was possible to put the policies in there, allow tiller to do whatever they wanted, but we don't see that as a good approach to just give some component complete access to everything in your cluster. We would like to have it more separated. I'm mostly repeating what you were saying in your presentation. And this is something that could come with Helm 2, or whatever is the version, the name that might be coming eventually, hopefully. However, for customers, it's a benefit, because we have seen, and you mentioned several companies that have been hacked. I think you didn't mention Tesla, that also had a problem. Well, oh, it was there. Okay. So with all the things, it might not have happened, but you never know, right? Like, security is always the best effort thing. So you always have to think that it can happen to me, but I do everything not to try to minimize the risks. So with the multi-tenancy in place, the cluster by itself is way more closed. So you cannot open the cluster as much to everyone. It's always a bit restricted. Container image management, I have heard that this might actually be coming into Kubernetes upstream as well. We call it image streams. It is essentially a history of an image in a registry. So let's say it's a timeline of all the different hashes that has been registered for that container. So I can assign different tags to different hashes, and I have the history in there, and I can move the hashes over the history. So the idea is that if I have a deployment and I specify that I want to use this specific image stream with this specific tag, it matches one of the hashes in the registry. When I change the tag to a different hash, essentially as you do with containers in the registry, we monitor that thing and we can start a deployment, because we know that this tag has moved to a different hash. But we always have all the history. So when you trigger a rollback, we know that when you are doing a rollback, it's not only that we want to have the previous replication controller or replica set. We know that there has been a different ID at the time for that specific tag, and we can move back even the container. Because in Kube, if you do rollback, you essentially replace the resource in Kubernetes, but you lose the information about the image, and the image can be retagged already in the registry, so you don't have the history of the whole timeline. So with this, it's way more easier to reason about where and what has been the specific container with specific hash running at the time. So if I do rollback or roll forward, I know to what hash I want to move and not to what specific tag what tag I has been using in the registry. Because one of the things that has been solved with the latest, what does it mean? Is it the latest version that has been released? Is it the master of my Git repo? Nobody knows, right? And whenever I do Docker push, I rewrite the tag. I don't know what was the previous hash with the tag. Yes.
Yeah, I would say that necessarily as a core feature, these wouldn't really make sense again on this, because you have CI on this that can do exactly the same thing.
Yeah.
Hashes or the tags compared to the repo, and then control that. So they would also CI, CD deployments, not on the
Might be.
orchestration itself.
Yeah, that's a good point. You can put this logic into the CI/CD pipeline that you are running on top of your distribution, probably, and have it there. Though I have seen discussions that they would like to move that into the core as well. I'm not part of the discussion, so I cannot give you the details, but I have seen that there was some discussion about that. Yeah, does it make sense? This is usually the thing that people never understand about OpenShift, like image streams. What the hell is that? Why do I want it? How is my time?
The meetup is quite over time, but you maybe have more time.
Okay. So one of the things is you want to do what you want to do to extend the core and put it into the upstream, or you want to build things on top of that. This is the thing that I see, or maybe my colleagues see, or we as a company see, Kubernetes as a kernel, as something that's there, like Linux kernel, right? Linux kernel by itself is useless. It's a great piece of thing, but it's useless if you don't have the distribution around it. If you don't have Ubuntu, CentOS, RHEL, or something, that's the opinionated way how to package the software, how to do the software release management around that kernel, around the thing. And the same, in a similar way, we see Kubernetes. Like Kubernetes is the kernel. It's something that you can take it and build your own distribution, because by itself Kubernetes will not help you as much, because you will need to figure out how to do CI/CD on top of that. You will need to plug these things together yourself, or you can take one of the distribution out there and use that one that already did the hardwiring for you. So one of the extended features that we are putting on top of the kernel is the CI/CD pipeline. So it comes as part of the package, so you don't have to figure out yourself. Right now we support only Jenkins. For the more complex pipelines, so you can create a pipeline that is essentially the Jenkins file. The Jenkins files is handled by OpenShift, and it passes all the information to Jenkins, and Jenkins is able to trigger containers, trigger deployments, and communicate with the cluster back. So essentially you have bi-direct communication between Jenkins and the cluster, and it's linked together. But not everybody needs something like that. Maybe people want something very simpler, and it's like, I have my source code, build me my container and run it, right? Nothing like that. So what I can do in OpenShift, again, this is the high-level features, is I can do OC, this is like kubectl for OpenShift, OC new -app, for example, Ruby, tilde, and GitHub repo. What it says is, hey, this is my source code, pull it from here, use a build container for Ruby, and create a runnable container that has the source code, that has the runtimes and all the dependencies. So you can just do, they can just, for example, pull it and run it as Docker run some container, right? So as to I, there is I over here that you cannot see. Actually, is the tool that is just a simple binary that takes the container, takes source code, and produces a new container. And the same is integrated also in the cluster, so you can do it in the cluster or you can use it yourself, completely independent from OpenShift. Yeah, so the idea is that you are an engineer, because we are a bit, well, not a bit, but very much developer focused. So we want to be able to do git push and have your application running, right? So it's not like I have to figure out how to write Docker files. I don't want to figure out I have any OpenShift. I don't want to see that. I just know that there is my Git repo. I do git push, and I have URL that I can check my application at, and that's it. So everything else can be hidden from the engineer if he doesn't want to see it. If he wants to see it, he definitely can have the access, because the role-based access allows the separation of concerns. So operations can give only the specific permissions to the user to see what he can do, or can do what it's allowed to do. And this is something that's coming. Have you heard about operators? Almost everyone, right? No, almost no one. So have you heard about CoreOS? That's also one of the distributions of Kubernetes that actually we as Red Hat have acquired. So the CoreOS is now part of Red Hat, and we are adopting the operators pattern. So what is an operator? In the basic sense, is a CRD. That means you create your own definition in Kube, and you write an operator. Operator is a controller. Is a controller, sorry, CRD plus controller. So controller communicates with the API, knows that your definition is being changed, and reacts to that. For example, I have a definition, kind PostgreSQL, size something, master 1, slaves 5, something. So when I create kubectl create-f my file, I will upload it to cluster, and controller sees, hey, there is a new definition. I should deploy a new PostgreSQL cluster, and it will create, it will pull the containers and put everything in place. Now, then it can handle upgrades, and it can manage complete life cycle of the application. It's really awesome for stateful application. That's why I'm using PostgreSQL as the example. Like when you have stateful applications, something that is not created with Kubernetes and the run as kettle in mind, then operators really help you to actually put all the logic that you would have to be doing manually into code and have it running as a container in the cluster, and automate completely everything in the life cycle of the application inside the cluster. There are controllers for different things. I think there is for etcd, for Vault, for Postgres. CoreOS created the Vault and etcd. Crunchy guys created the Postgres one. And different databases, mostly databases now have operators in place, and you can start using those. Yeah. So what is great about it is that you don't have to change at all the cluster. You don't have to touch anything inside. the code of Kubernetes. The only thing is you need cluster level access to define the new CRD, and then any user can upload their own CRDs, create the resource, and can then controllers then can handle these resources and do everything in there. So you don't have to understand how Kubernetes on the code level works internally, but you just communicate through the API and you understand what you would be doing using kubectl on your YAML files. You just do it in a component that's long running inside the cluster. Yes, so this is my last slide. Now, small plug. We are running OpenShift Commons Gathering. So if you would be interested in hearing more about OpenShift, specifically about the distribution, September 10 here in Helsinki, in Red Hat office, I will be there. So come there and see. There is a code that you can use for registration and the URL. If you would be interested, take a picture. Tanya over there, she is the organizer of the event, so if you take a look, you can speak with her about it. And she promised also that she will put these things into the meetup page or something like that. Yes, she's waving and nodding, so should be done. Yes, I think that's it. Thanks for coming. If you have any questions, feel free to ask. No questions?
Have you taken a look at the Knative project?
Knative. I know it was released. I didn't have time to actually take a look at it.
It's a good example of how operators see that, and all this is basically like it's the making Kubernetes cluster as a serverless platform.
Mm-hmm. Yeah, I have it on my to-do list, but the to-do list is this long, and just it didn't pop that high yet. But it's something that I am aware of, but I didn't have time to actually poke into. Yeah. Okay, so get your beers.
Hey,
Thanks.
just to notice, beers has been restocked. So if you're just wondering if beers run out, no, beer doesn't run out. There are more beer.
Okay, and again we will have one more talk, but we'll take a 4-minute break to set up the HDMI and everything, and then we'll probably finish to 9 p.m. Yes. Okay, let's start again for the last talk of the day. And now we're going to talk about, so normally we do a lot of container orchestration, and as Jerry also said, containers are great, but there's isolation, yes, but not full kernel isolation. If you have something really restricted workload, you might want to run your the binaries in the container in a dedicated virtual machine instead of in Docker, for example, or CRIO. And these guys are going to talk about how to do that, how to switch out containers for VMs for specific workloads. Enjoy.
All right, can you hear me? Perfect. So, as already said, because we are here in the Kubernetes meetup, we know you love all these hipster technologies such as Docker and containers and microservices and Istio or whatever. So that's why we're going to talk about virtual machines. And more precisely why you're gonna, or how can you orchestrate using Kubernetes. But first, shortly about ourselves. I'll do this really quick because we're anyway over time. My name is Severi Haverla, and this fine gentleman next to me is Niklas Tanskanen.
Good evening.
And we both come from a company called Ethicode, which is the leading DevOps house in the Nordics, expanding rapidly in Europe as well. But yeah, that's enough about that. Let's move on to the topic. So, how can you actually run your virtual machines on top of Kubernetes? Well, we present two different options, and actually we're going to talk more about the KubeVirt, but I'll shortly talk about Virtlet as well. The main differences between these approaches is that how they look at the virtual machines. So whereas the Virtlet, it wants to treat the virtual machines more like pods, so more like cattle in a sense. The KubeVirt is made with the approach to introduce the pet VMs to Kubernetes as well. And so the underlying architecture is also a bit different between these two. But I'm going to focus on KubeVirt in this presentation, or VR, and we're going to have a nice demo about it later on as well. But how it basically looks like, so it actually utilizes the operator pattern that was discussed before. So KubeVirt, it extends the Kubernetes API with a custom resource definition, and it has a controller running on the master nodes that listens to these resources. And what the resources are named, it's basically virtual machine and virtual machine instance. And when a new virtual machine is created, basically the Virt controller will schedule a pod to the nodes using kubelet that will eventually run the virtual machine instance. And on the pods that are able to run the virtual machines, there you have a daemon set running with the Virt handler, which will then basically recognize that, okay, now we have a pod that's going to be running a virtual machine, and it will handle all the necessary logic to set up the virtual machine running there. And of course, we also have, because we have some stuff that cannot be handled with the kubectl or kubelet. So for example, if you want to set up a VNC connection to your virtual machine, so KubeVirt also introduces its own command line tool called kubectl, virtctl, I guess. And with that, you can, for example, have a VNC connection to your virtual machine, and that will actually won't use the kubelet at all. It will have directly access the Virt handler, which will then do all the magic there. But enough about that. Why would you actually want to do this? Why would you want to run the virtual machines on your Kubernetes cluster? Well, there are a few reasons. One is that not all the applications in the world are in a state that you could just put them in the Docker and running on Kubernetes. That's not going to work. And maybe you don't want to put all the effort into making them container ready yet. But this enables you to run it on Kubernetes together with, for example, your microservices in the same network, and handle them the same way you handle or your containers. So this is quite nice. And maybe you can eventually start containerizing your old school application running on the virtual machine, but you can already have the whole infrastructure there in Kubernetes. Another thing, provisioning new virtual machines on the cloud, it might take some time. But actually, using this kind of an approach, it's a lot of faster. So this is a good or for if you want to get your virtual machines launched quickly, you might want to try this out as well. And a new buzzword, unikernels. So this also introduced the option to run unikernel workloads on your Kubernetes cluster. So basically, you take really minified virtual machines that only has like the specific kernel stuff there that you need to run your application, and you run that on your nodes. So you don't need all the additional hassle that's there. This also this also enables you to create really small applications or unikernels, or however you want to call them. So for example, a web server created by the Mirage OS, it only takes less than a megabyte, whereas the Nginx Alpine container has 18 megabytes. So there's a big difference there. That's just an example. And of course, you want to run Windows on your Kubernetes. Who wouldn't want to do that? And let's move on to the actual demo.
Right. Who likes Windows? Nice, nice. I love you guys. All right. So I have one Kubernetes cluster set up in the Google Cloud, one of my own making. I've installed KubeVirt into the cluster. It's a one node installation. And what I want to do is I'm going to run Windows Server inside that Kubernetes cluster one node server. So here I am in the Kubernetes cluster, and I already have a virtual machine running there, and I can query using the kubectl command object virtual machine instance. Its name Windows 2012 R2, and in the spec, like every spec in the Kubernetes, I have a clock set up, I have a devices, I have disk here, and which bus is going to use. All of these are directly going through the libvirt to the KVM running the virtual machine. I'm free to add maybe a network adapter to the machine, or add more memory or whatever. And I also have an IP address for the virtual machine. So if I do this, so I only have two parts in the cluster, but this is the IP address of the actual virtual machine running in the Kubernetes cluster. And if I go to another part, this is going to take some time. Here we go. And just simply get, so I have an IIS server running in that virtual machine, and I can actually get the web page that is served by the IIS from the another pod. So the pod and the virtual machine are seamlessly connected to each other. If I would have a perfect setup of Kubernetes, I could also do a load balancer type of service and expose services running in the virtual machine to the outside world. What else? I also have VNC, so I can just simply use the VNC command and gonna find, here we go, there we go. So this is the virtual machine running inside the Kubernetes. I can play with it, I can browse the internet if I want. But I think most useful case would be to run test automation inside this virtual machine, because you cannot do that if you had just Windows containers. And some users still need to use Internet Explorer or Edge for some reason. So this is the one way of doing browser testing with Windows inside Kubernetes. I think this is only the only solution to do that. Or if you need, for some reason, Jenkins slaves that are running Windows, you can do that as well with this solution. And what's the most clever part here, that I can actually, or I would if I have had a correct key layout set up, I can reboot this. Stupid Windows, come on. Oh, okay, I give up. I was about to reboot the machine, and the disk actually persists. So I can configure this however I want, and the disk persists in the Kubernetes by a Kubernetes persistent volume. Yeah, that's it. Any questions? Yeah, yes and no. It's much better if you have a KVM and it can fully utilize the CPU, the VMX flag. It's much better that way. But you can run it in a software emulation as well. Yeah. It's based on that, but you can run it without it as well. Yeah. What do you think? Come on, man. No, not even in staging. But it's a cool idea. Huh? This is running in the Google Cloud VM, and it has the nested flag enabled, so that the VM can run on other VMs, and the Windows machine is running in a VM in a Google Cloud.
You can share your Kubernetes manifests.
Hmm?
Can you share your Kubernetes manifest file?
Yeah, I can. Yeah. I think we're gonna make all the presentation and the manifest available in the meetup page or something like that. Okay, cool. More questions? No? No? Okay, cool. Thank you.
Okay. Thank you to all the speakers. It was really great to see this amount of talks. This time we had a bit shorter meetup last time, so we made it a bit longer this time. And yeah, so if you thought this was too long, comment. I think we will send out a feedback form in a couple of days. We will also, I think, upload the videos. Yes, let's let's hope the video, the audio's with us this time. And yes, we, as a hook for next time, we are always looking for more speakers. So if you'd like to speak, or you know somebody that is willing to speak at this kind of event, we have a CFP form up all the time, so you can anytime apply for any meetup that is going to be scheduled. Tentatively, we're looking like 2 months about from now for the next one. We'll think more about that in the coming weeks.
So if you submit now, you can still affect when the next meetup will happen by telling why you want to speak. So.
Right. Right, now you have a chance to decide. And yeah, I personally thought it was really cool to have yeah, have this amount of speakers, and it's really great that we can start get this rolling, so I don't have to speak every time. And we also would like to thank our sponsors. You can.
Well, yeah. Thank you all. Thank you. Yeah, thank you to all the sponsors, and of course we have Emblika, we have Lucas's company and CNCF. But of course this time the biggest applause goes to Elisa, so thank you for them. Yeah, and I think that's it. Do you guys have anything else?
I just have something. Okay. So a little bit applause for Lucas and Aamuja. Okay, thank you. And well, somebody from Elisa could tell like what happens next.
What happens next? Next, there's beer left, so we have no hurry to get out here. We can stay and have a beer like 10 p.m. if you wish. So grab a beer, mingle, talk to each other. Come talk to me if you want, or there. Thanks for coming. Great to have you here. We are happy to host the meetup again.